We're going to look at test of means. The file we are using is per capita income. First, to investigate the differences between per capita income of different macro regions in the world. Let's run a graph. In Graph Builder, drop the variable country into map shape. We'll get the map of the world, and then use per capita income, drag it into color area. You can see there is a spectrum of colors, and it starts from dark blue, lower per capita, towards red, higher per capita. Double click and click on color theme and change this theme if you want. Let's now look at the distribution of per capita income. Run a graph builder and drop per capita income into x-axis. Click on histogram to see the histogram distribution per capita income for the world, and then divide it per macro region. If you drop macro region into round box, we'll see histogram for each one of those 6 macro regions. As the whole world shows, these macro regions are skewed, which is lower per capita income. We have more concentration, more countries than to the right, upper income. Now we have minimum information about the distribution of per capita income. In macro regions, we know they are mainly right skewed. Start analyzing by running test of means. We use fit y by x. Per capita income, which is the continuous variable of interest, goes to y response area, and the macro region into x for a factor. And by the legend on the left side, we know that in one-way analysis, if y response is a continuous variable and x or factor is nominal or ordinal, we should expect a one-way analysis. This is the base for one-way analysis. We have our macro regions, observations for per capita income stacked up, and then from the red triangle drop down, we can see all those tests that are available here. We can run test of means ANOVA, analysis of variance, because our groups are more than 2. And we can use nonparametric tests under Wilcoxon test. We know Wilcoxon is for only 2 groups, but if we have more than 2 groups, the test, nonparametric test, will be automatically Kruskal Wallis. We start with analysis of variance. Just by clicking on ANOVA, we will get this output. By looking at analysis of variance table, we can see there's an F-test done, and the significance is a very small number, as indicated here, less than 1 in 10,000. That means we observe a statistically significant difference among the means. We have assumptions for ANOVA. To run ANOVA test, we must have normal distribution of the samples and homogeneity of the variances. All the samples in hand should have equal variances, or the variances being in one group not being significantly different. There is a test available here on equal variances. If you click on unequal variances, this is a test of variance that you see here, and 4 tests of different variances are done here. Look at Levine test because it requires the least assumptions among all. The test statistic is small, well, depending on the significance level we consider, typically 1% or 5%. If we get a number less than 5%, then it shows a significant difference among the variances. Since the variances are significantly different, then analysis of variance is not a valid test. In that situation, we rely on nonparametric tests. If you click on Wilcoxon, and as the screen tip shows you, Kruskal Wallis will be the test for more than 2 groups. At the bottom of the page, we can see the output for Kruskal Wallis test. Test the statistic down here. The chi-square test is done, shows the significance. The means of these groups are significantly different. At least one of them is significantly different than the others. Additional information we get here is on the column to the right. Mean minus mean 0 divided by standard deviation. Well, this is the formula for z-score. We can see how different the z-scores are. Negative 7.8, 6.3, the two extremes, and then the other numbers in between. So the conclusion is that there are significant differences among the means of these 6 groups.